Kelp is a visual development platform that empowers developers to quickly and easily build real-time data applications. Let me show you how it works with an example. Imagine you are operating a chain of kelp shake restaurants that are mysteriously spawning all over Manhattan. Your job is to ensure that all locations are operating smoothly. To achieve this, you need to track several key metrics and trends. To build this dashboard, we need to pull data from multiple sources, including a real-time feed of current orders, historical sales data in Postgres, and REST API of inventory system. With Kelp, you can build it pretty quickly. Let's begin by connecting to the streaming SSE endpoint to receive the incoming orders feed. We specify the URL and request parameters. To view the data, we first need to add a buffer component to collect all the incoming events into an array. Kelp will apply the corresponding security credential for us by using the integrations that you can pre-configure for your apps. Then we connect it to a table widget. For those new to this concept, Kelp uses a visual data flow approach for building event-driven applications. It involves nodes or components with various ports that are connected to one another using wires which carry data between them. Rather than writing code in a traditional language, you connect components with wires. Let's now count and display the number of open orders. We will add the metric card widget and connect it to the buffer output. To perform the count, we'll use a transformation on this wire. You can apply transformation expressions to any wire. The expression will be applied to every event that passes through the wire. Kelp supports KelpQL and GMS paths, which are pretty powerful JSON query languages that help you to manipulate JSON data. We'll set the name and value for the metric. The widget will display the metric as soon as it receives the data. Similarly, we can configure all the other metrics. You can easily copy and paste widgets and connections. Next, we will create a bar chart using Vega Light chart to display open orders at different stages aggregated by time interval. This will allow us to see how quickly orders are being fulfilled. We will paste and connect the spec and connect widget to the data. We will also need to filter out delivered orders to focus only on open orders. Kelp supports Vega and Vega Lite visualization grammars, which offer a wide range of expressive data visualizations. Next step, we need to be able to filter out data by location, order status, and delivery service. To achieve this, we will use the cross-filter feature. We connect our data stream to the cross-filter component, which acts like a mini search engine. It combines and applies filter criteria from multiple dimensions and outputs the reduced dataset. To generate all the necessary filters, we will add helper components, cross-filter dimension and aggregation. Set the group by field to location and configure the aggregation function to count by order number. Then connect the list widget to the cross-filter dimension output and pass back the selection and filter to cross-filter. The list widget will display all the locations. Selecting a particular location will filter out the entire dataset. Now let's connect the chart to the cross-filter results so that it also cross-filtered. We will also configure the status and delivery service dimensions in a similar way. The next step is to retrieve historical data from the Postgres database and use it to populate charts with daily and weekly sales numbers. To do this, we will use the SQL DB connector and feed it with the corresponding SQL query. Then we will extract the result and use them to populate 2 additional charts. The first chart will display today's orders and orders from the same day of the previous week. The second chart will show aggregated daily gross sales for this and the previous week. To slice the data by location, we will insert another cross-filter in between and link it to the filter generated by the location dimension above. Lastly, we will display the current inventory levels for each location. We will use the REST API of our point of sale system and parameterize the request with the location selection. We will then normalize the values and feed them to a bullet chart. that shows the relative inventory levels. And finally, we'll switch to the layout editor and place all the widgets where we need them. We'll add a title text to the top and make a few minor adjustments to make our dashboard look nice. We have just built a real-time operational tool that can be immediately released and shared with your team. You can also invite your team to collaborate on building apps together in secure, controlled workspaces. To summarize, Kelp is a visual development platform for creating interactive real-time data apps. It can connect to a variety of data sources, and it provides a rich library of data processing and visualization components. With Kelp, you can design, develop, and deploy mission-critical operational tools all in one place.